come now to our third lecture now in our lecture series focused on a discussion of the future of the engineering profession and how engineering education should respond to that. So the title of it is Engineering Leadership for the Conceptual Age. So the idea is that we recognize that the world is changing. The value proposition for many our companies are changing, particularly our technology-based companies that hire engineers, and because of that, over the next decades, they're going to need engineers with different type of training, and that's what we're here today to continue that discussion, to look at how engineering education should respond to that, and what are the options for you as students going into an engineering career. And I want to talk a little bit about the fact that we're doing this discussion on the lead up to the centennial celebration of the university. You should all know, I think you see we have a new logo now for UTEP that has 1914-2014 on it now, with our Bhutanese architecture on that. So we're getting ready to celebrate our 100th anniversary in a couple years. And that's very significant for a couple of reasons. I mean, first of all, it's important to know where we came from here as a university. And even as students now, that you're just here now, I think it's important for you to understand where the university came from and the position of the university here in the community, and why that's so important. When I talk about the UTEP story, the first line I use all the time is, it all started with engineering, because it really did. UTEP started as the Texas College of Mines, and then eventually later expanded out beyond engineering and became Texas Western University, and then eventually became a formal unit of the University of Texas system and became the University of Texas at El Paso. And those name changes are somewhat indicative of the evolutions the university has went through in terms of redefining itself and redefining its role here in the community. It started out as a university that was responding to the economic needs of the community. This community was a mining community and needed mining engineers, and responded by creating this program. And much the same, the university has responded to the market, and particularly the local market here, in terms of what the needs are. And that's where we are right now, is becoming a national university with a 21st century demographic. And what that means is that we want to have national impact, but also relevance and importance to our local community and local region that we serve as well. And I say that, I'm talking about the history of the university, to also note that there are a number of organizations that are celebrating their 100th year. That 1912 to 1914 time frame must have been a very innovative time here in the U.S., because there are a lot of organizations, I'm finding out, some of them here local here as well, that are celebrating their 100th year. Well, another organization that is celebrating their centennial, their 100th year anniversary this year, is IBM. And if you look at the history of IBM, they're, not that I want to equate UTEP with IBM, but there's a lot of similarities in the fact that IBM started out, with fairly humble beginnings and sort of focused markets, and then has changed and evolved according to the markets. And most recently, they are evolving now from a product-based company to a service-oriented company, which is very indicative of the profession of engineering, changing a little bit more from a product-based profession to a service-based profession. And so that fits in with our theme here today. Well, to celebrate their 100th anniversary, IBM is sending out its best and brightest and most important people to go to universities and talk about the impact of IBM on the way we live and on technology, and to talk about where IBM and where the engineering profession and where academia goes jointly together. So we are very lucky to have today here with us one of those people, Wilfredo Sotolongo. I got to know him a little bit today, and very impressed, and I know that you will be as well. Even as an individual, he kind of fits the model of the type of engineer that we are creating here. We want to create engineers that can go in a variety of different career paths, and he is another model of that. Let me tell you a little bit about Mr. Sotolongo. He started out as a very classically trained engineer, aeronautical engineer, trained out of Embry-Riddle University in Florida, graduating with a bachelor's degree in aeronautical engineering, and then he went on to Georgia Tech and got a mechanical engineering degree, very classical kind of engineering degrees. He ended up, though, at IBM, and he's been at IBM now for over 25 years now. And he's had various technical positions there, but then he also very quickly went into management and executive type of positions. He was at one time the vice president of System X sales for all of IBM North America, but he has now just recently been named vice president and business partner in mid-market sales for IBM North America. As such, he reports to the general manager of IBM North America and responsible for IBM's channel strategy and for developing and executing sales and marketing initiatives to grow IBM's business through the network of business partners in North America. He's further responsible for all business results and customer satisfaction of IBM clients and mid-market customer agency. So you can see he's gone from a very classical engineering training into a job that requires him to deal with the most complex technology that we know, and that is ourselves, the human being. And he's going to tell us a little bit about that. So help me welcome Mr. Sotolongo.
Thank you, Richard. Appreciate it. Thank you, Richard. Appreciate it. Whoa. And good evening. Buenas noches. Is my voice okay? Can you hear me fine? Because I actually hate microphones. First of all, let me start by saying thank you for the hospitality. I've spent a wonderful afternoon here with you, Richard, and the students and the faculty at the university. I live a very hectic life, and it's a life full of stress and travel all over North America, and I rarely get the opportunity to kind of sit back, relax, reflect, and think about the big issues that are facing our country, right? And we talked about all of those here today. So to me, it's an honor and frankly a privilege to come to El Paso to get to know you and to share some of the thoughts, some of my experiences after 26 years at IBM that hopefully will inspire you to do what you will do in the future here for yourselves and for our country. Before I embark upon the formal discussion, I'd like to get a sense of the profile of the students here. So I'm going to do a bit of a random survey. How many of you here are engineering degree students? All right. How many of you are computer science or information systems students? Oh, wait a minute. Why the same hands went up twice? Because they consider them one and the same? Well, then I should be more specific. Mechanical engineers. All right. Computer science majors, or the majority. Okay, that makes sense. That's why. All right. What other degrees are in the audience? Electrical, civil. All right. All right. Any degrees outside engineering?
Graphic design.
Graphic design. Okay, great. So most of the audience here is information system. Makes sense. I'm an information systems guy. I think it would be helpful to tell you a little bit about myself. I am an aeronautical engineer by training. I had a passion for aviation since I was a kid. And I went to the school, the only school I applied to and admitted me, because I thought it was the best place to go for such a degree. I quickly learned that as a non-US citizen, I couldn't work in that industry. Even though I graduated as the #1 graduate of that school that year. So I decided to broaden my horizon and joined Georgia Tech and became a mechanical engineer with a master's. And what that did is precisely open up a world of opportunity that I never imagined, absolutely never imagined. Information technology was not in my plan, not at all. But in those years, IBM was booming in the early 80s. And they visited campus, and they made me 3 offers to work in 3 different places. And the offers were absolutely incredible. So this is the power of an engineering degree. One offer was to work in Austin, Texas, designing the print heads for our IBM printers. Another offer was to work in Poughkeepsie, New York, designing the semiconductor manufacturing lines where we make the microprocessors at the time. And the last offer, and the one I accepted, was in Boca Raton, Florida, next to the beach, designing robots. That was my first job at IBM. I actually did mechanical design and programming of robots, industrial robots. So I couldn't believe it. I had a $3 million a year budget that this 22-year-old kid was managing. That's the power of engineering. That's the power of applying yourself well so that you get those kind of opportunities. And yes, I was one of the best students out there. But there were a ton of other people just like me that got those incredible dream jobs when we graduated. So if you're having any doubts about whether you should pursue this career, get them off your head. This is the best door-opening career there is in the United States. Not an attorney, not a doctor, an engineer. Yeah, attorneys and doctors do well. But engineers actually can do just as well or better. So, now, with the formal engineering training, after 2 years, I hated engineering because I was a social person. And I wanted to be outside. I wanted to interact with human beings and people. And I was blessed to work for a company that at the time was extracting its engineering talent from the factories and putting them in front of clients. And that's how I joined sales. I didn't know how to sell. I didn't know how to make presentations. I would have been shaking 24 years ago. If I was doing this, I would have been shaking. But they trained me. They helped me develop the social skills, the presentation skills, the listening skills, the organizational skills, the relationship skills to listen to clients and build solutions, IT solutions that help them, fix their environments. And it was the best thing that happened to me, to have started with a very technical background and then have the option to go into a very non-technical world, quite frankly. Any of you could beat me in technical discussions today. You can't do it the other way around. You can't start with a liberal arts degree and then get technical. Can't. So if you're having doubts about that, go the technical route first, then do the other path. So enough about me. Hopefully that helps put in context your own life and your own future. As you heard Richard say, IBM celebrates its 100th anniversary, 100-year anniversary. This year, we actually completed our celebration in September. So I want to tell you a little bit about our history, but I want to do it in terms of putting in context the lessons that we think we've learned from that 100-year history, and how those 3 lessons will influence the future of this industry. And hopefully, you'll be so excited about the future of this industry that you will all graduate in a hurry and get out there and help us build it. You made a comment that a lot of institutions were founded back then in the early 1900s. In the technology field, there's only one company that survives that was founded back then, and it's IBM. And the reason it still survives is precisely for what you said. Its ability to change with the times and move where the puck is going to be. Does anybody know what IBM's first product was back in 1911? You're going to laugh. Meat scales. Meat scales. We actually built scales to weigh, that butcher shops would buy to weigh the meat. That was IBM's first product. By the 30s, we were into, well, is this working or not? By the 30s, we actually began to get into the computer. We actually began creating the computer industry by inventing a lot of technology that today is taken for granted. By the way, I didn't make the comment, but I hate one-way conversations. So, if you want to interrupt me or approach me like some of you already did, please do so. I don't care. Because the only way this is useful is if it's useful to you, not to me.
Did you have a lab structure like Bell Labs at that point in the history of the company?
We did. I don't know how far back it goes. It certainly didn't go back to 1911. We have the largest research we are the single largest research institution within the technology sector in the planet today and have been that way for the last 30 years. We also have the largest number of patents for the last 17 years in a row. I think we're putting out about 5,500 patents every year right now. So if you go to our Georgetown Heights Research Center or our Zurich Research Center or our Yamato Research Center in Japan, or there's one in China, I think it's in Beijing, there are thousands of scientists that are thinking and developing that next set of technologies that will shape the future products of the company. These are some of the 100 icons I was alluding to earlier today that reflect on some of the inventions of people like you that joined IBM decades ago. How many know that IBM invented Fortran? How many of you know that IBM invented the hard disk? Okay. How many of you know that IBM invented fractals? It's an IBM scientist and invented fractals. I think we have 4 Nobel Prize winners inside IBM. Actually had, some of them are already retired. Incredible, culture of innovation, creativity that started deep at the core of technology with people like you. With people like you that did this. So when you reflect on that and you realize the contribution of these human beings and this institution to society, you have to ask yourself, wow, what are we going to do next? So we perceive 3 lessons from this 100-year journey. The first one is about the application of information technology and its nature. It's been constantly evolving for all 100 years. And I'll dive into that a little bit more. The second one is about what could happen with this technology-infused planet we got. And what are the possibilities? Here's where you come, right? What are you going to invent with the capabilities that we are developing that are now widespread in our planet. And last, our point of view on how management and leadership needs to change going forward in this technology-infused planet. So it's not technical, it's not scientific, but it's reflection of 100 years of learning of an organization that keeps morphing and changing to survive. So you reflect back on the contributions of information technology, you can easily conclude it was the most important science of the 20th century. Now, I'm obviously biased, and many of you probably are, but it was the most important science that unfolded in the 20th century. The progress made by mechanical calculators, tabulating the census in the 30s, the whole Social Security system was built because we had that technology. The air traffic control system that was invented in the 50s in order to support the jet age was all based on IBM mainframes and computers at the time. The trip to the moon, the space shuttles, all of those were built on technologies invented in those years. The invention of the PC kind of democratized technology to the whole planet and made each and every one of us a programmer and a user. The resurgence of the internet, creating standards and interconnecting us so that we are able to collaborate across long distances. Each and every one of these steps, this evolution, has been building on top of the previous one. They are not independent, wild, random evolutions of a system. They are, in essence, one is the base for the next one, for the next one, for the next one. And we believe right now we're building the base for the next one. And the next one will be even bigger and more dramatic and more impactful. That picture right there is a Chevy Volt. That's a car, right? But I think it's got 10 million lines of code. And we know that because the code in it is IBM code, okay? To control the electromechanical devices that drive the automobile. That last picture here is Watson. Anybody know what Watson is? Jeopardy. The worldwide Jeopardy champion, an IBM computer. And I'll speak a little more about that. But it symbolizes the evolution not only of a firm, but of a whole industry, from a bunch of tools and products to an industry, to a science that you're studying that will move on to a next stage. We believe it was the most impactful industry of the 20th century and can be the most impactful science of the 21st century too. Whoops. Now, that industry was based on a bunch of basic technologies that you all know, frankly, much better than I do. These are the same technologies that built this industry 50 years ago. Processing technology, connecting technology or network technology, memory or storage, logic or programming, sensing, the ability to interconnect and interact, and architecture to put it all together in a coherent way. These are the same basic building blocks we've been working on for 50 plus years. But the underlying elements keep changing and evolving and enabling new systems of systems that are getting larger and more complex and therefore more capable to solve human problems. Because in the end, technology only exists to solve human problems. So while there have been tremendous breakthroughs in all of these areas, it is the architecture and the integration of all of these breakthroughs that enable us to build solutions like the ones I'm about to talk about that actually solve human problems. We believe we're now entering a new era. You could say the first 50 years of the 20th century were the electromechanical era, the tabulating era. That was the very beginnings of the information technology industry. The next 30 years or so, maybe 40 years, we call it the computing era. This is when, computer processing power, whether it was the mainframe or the PC, spread out and made possible all the wonderful applications that you're all familiar with. We now believe we're moving to a smart systems area. And what we call by smart systems area is systems of systems that are self-healing, self-managing, self-learning, kind of scary stuff, right? And some of you actually were using the word artificial intelligence here earlier, which is actually a very old term, which is coming back. We believe the underlying silicon horsepower is getting to the point that that is going to be so cheap to compute that you'll be able to do things we can never dream of doing before. We believe this era began really with the internet, the emergence of the internet and the ability to interconnect and collaborate across long distances and across time zones and countries. But we believe when you infuse on top of that things like predictive analytics, self-learning algorithms, you'll be able to do things like Watson, right? How many of you actually saw Watson play? I see about a quarter of you. Wasn't it eerie? To me, it was eerie to watch it play. Now, obviously, I'm an IBMer. I was very proud. But I almost attributed feelings to the thing, because it sometimes provided answers that were funny. They were wrong and funny. This is actually Watson. It's hard to see in this slide, but this is it. It's a room full of computers, okay? It's got the most powerful microprocessor in the planet. It's called the Power 7 microprocessor. More powerful than anything Intel has invented so far, by the way. But that's not the exciting part. It's all of the software that went into it. It's all of the engineering talent and the scientists that worked with it for 4 years to teach it so that it could answer totally unexpected questions with the double meanings and all that stuff that is a classic Jeopardy game. And we spent 25 scientists for 4 years teaching this machine so it could compete in Jeopardy. Not to win the Jeopardy game, but to demonstrate and inspire people like you as to what the possibilities are. There are Watsons getting deployed right now in the United States in the healthcare system so that doctors can provide some input to it, and it will provide more accurate diagnosis than ever before. It's already happening. There are Watsons in the United States right now going into financial services institutions and banks to help them figure out the optimal economic way to make some profit in the stock market. There are Watsons going into the United States today into our national security agencies. Yes, sir.
How many are there so far?
Watsons?
Yeah.
I personally know of at least 3. Now, each one of these Watsons costs, $20 million plus, okay? Yes, sir, bye. If you think about the ability to interpret human language, and I don't mean voice recognition, interpret human language and the meaning of the different words, you begin to understand the capabilities that are ahead of us. If you begin to understand the fact that we are feeding this machine a bunch of data, a bunch of information, libraries, encyclopedias, internet, and let it learn and accumulate and create interconnections and relationships, you can imagine the capabilities we're going to have a few years down the road, because the computing horsepower is only getting cheaper. We think, at IBM, we think that we need to do this simply because, in spite of all of the efficiency and all of the effectiveness of our society and our systems, there's still a lot of waste, a lot of fraud, a lot of unused assets and resources. And in this, I'm going to call not so smart planet, as we, pass the $7 billion mark in population, and we, stress the natural resources, we need to make the use of all of these natural resources and systems far more efficient. So it's technology like this that will allow that to happen. Couple of quotes. 22% of the port volume in the United States is empty containers. That's waste. $2.2 million dispensing errors in the medical system in the United States today. That has consequences in healthcare, right? Lost work days. Many million dollars of fraud. $100 billion of fraud. A lot of it in South Florida. That some of these intelligence systems could detect and prevent. This fraud, we all pay for fraud, right? I was surprised by this. LA cars trying to park. 47,000 gallons of gasoline because we're not controlling our roadways correctly. A lot of waste. A lot of carbon dioxide into the atmosphere. There are systems now, there are traffic systems now that prevent this from happening. In Stockholm, Sweden, there's one. There's one in Singapore. And what it is the integration of all of these different hardware, software, and systems to drive human behavior by charging you fares, depending upon the time of day and how long you are in a particular area of the city. Here's the opportunity we see with a technology-infused planet. We see everything getting instrumented. I was looking at an ad. They can put RFID tags on you now. Do you know that? RFID tags on you. They can put RFID tags on your pet so that you can find your pet if you lose your pet. They're putting RFID tags on anything that moves in the supply chain. They're putting RFID tags on basically anything in the transportation system. And with our RFID tags, you can track anything about that. So as you instrument the world with all of those sensors, there is an incredible offload of data that is going to be available to make decisions. So it begins with instrumentation of the whole world. With the internet, you can now connect it all. You can have cars talking to cars. You can have appliances talking to service departments. You could have airplanes talking back to their home base. You connect it all through the internet. And you begin to create such a massive interconnected world that it will allow you to be very intelligent. Because as you're sensing and detecting all of these events around the planet and sharing that information, and then you apply these very powerful analytics tools, predictive analytics tools, you can begin to ask what-if questions. What if we implemented this toll in this road at this price for this time? What will happen to traffic jams in the city of Miami, Florida? What if we dispense medication this way or vaccines this way at this population over this geographical area? What kind of reduction of the incidence of some kind of spread of disease? we see the capability to interconnect this to solve some of the hardest problems of humanity. So in this technology-infused planet, it's already here. We're just not putting it together. In 2001, there were 60 million transistors per person in the planet. Today, there's 1 billion transistors per person in the planet. 10 years from now, who knows? It might be 1 trillion transistors per person per planet. That's a lot of intelligence and raw horsepower that is available to think, to process, to interface. Out of 7 billion people, 4 billion already have cell phones. Think about that. 4 billion already have cell phones. That's almost 2/3 of our population in the planet. And the cell phones are getting smart. They're computers now. They're not cell phones. So that means that in about 5 years, by the time some of you will be going into the labor force, we could well have 3/4 of the planet's population with computers on their pocket. Think about that. Even the poorest person in China or in Ethiopia or South Africa will have a computer in their pocket that can do all the things, all the wonderful things that those of us that are privileged to have them now know they can do. RFID tags, I alluded to this. There are 30 billion of them out there, and it'll probably be 1 trillion RFID tags. So just about anything that moves can be traced and tracked. So this technology-infused planet is happening, is invisible. Probably the cell phone is the most visible aspect of it, but everything else is already happening. And what is missing is the glue to bring it all together and make it useful, make it fix problems of society. So in our case, we're working very hard to create these systems of systems that leverage these technologies. It may sound boring. I worry that this sounds not technical and not boring, and not, if you're in information technology, I like to program, I like to, build algorithms and subroutines and whatever. Let me tell you, they're all worthless if they don't solve human problems. Because people spend money to solve human problems, and only to solve human problems. So, 2 billion people already on the web. 2 billion people already on the web. Probably be 3 billion in about 3 years, right? Almost half of the world population. And most of them will be accessing it through the cell phone. So, this Internet of Things is the new infrastructure. Is the new IT system that is being built. It is not a data center. It's not a computer center. It is not your PC. It's not your iPad. It's not your iPhone. It is this interconnected animal that is sharing information with each other. There are multiple applications of hardware, software, and services in this IT industry that solve business problems. There's some of them here. I'm actually going to skip them in the interest of more of a dialogue here between us. But trust me, cities, governments, academia, school systems, all of us have the opportunity with this technology-infused world to interconnect and interact and help and support and predict and change a lot of the world with this information technology. So that's what gives us the hope that after 100 years, in our case, we're still like in the infancy of this world. And as an ecosystem, including companies like Apple with this very, very creative user interfaces, their iPhones, their iPads, or other companies that specialize on microprocessors like Intel, we're building an infrastructure, an IT infrastructure, that is embedded in the fabric of the planet. And that you all, as the future leaders of this industry, will shape into the future. So, finally, our point of view as to what are the issues with this, right? What do we need to worry about? We believe that the only way to unlock this potential is by embracing open standards. And when we say embracing open standards, we're not talking about IT open standards. So don't hear into that Linux. Linux is an open standard, but that's really way down there. We're talking about open standards all the way up to the business processes that support our society. So that, for example, our healthcare system can interconnect and exchange information with our government systems and our education systems. So, so that companies no longer have to have a physical presence in a particular location. They could be distributed to where the skill is available, and at remote distances collaborate and interact and bring the creativity of people all over the planet upon a particular problem that you're trying to fix. IBM actually in its history was perceived by many to be a closed systems kind of company. And we were, in fact, because the original IBM mainframe, which kind of set up this industry, was the IBM mainframe, and we didn't like anybody messing with it. But we learned the hard way in the late 80s, early 90s, that if you have closed systems, you get to be an island, and you get isolated, and you get disposed and discarded. So we've been strong proponent of open standards in the IT industry, and we're now trying to lift that discussion to processes and policies at all levels in society, so that we can help transform the way we interact across the planet. Free trade, you could say that's a standard. Second, there are some significant risks that come to the forefront with these capabilities. The first one is privacy. In fact, I'm surprised nobody already hasn't said that. There is the potential threat to violate everyone's privacy with the infusion of this technology everywhere. And we have to come up with standard policies, government policies, industry policies to protect privacy, so that we're not tracked when we're working around here in the UTEP, on our cell phone, right? Or so that the Chinese government, who is still a communist government, let's remember that, and the Cuban side of me came out there, doesn't use the same technologies that we are not worried about here in the United States because we're a free society, that they use it there to control their society, right? So that's the first one. And we don't have agreement on privacy policy in this country or in this planet yet. So we got to develop that. Secondly, security. If the IT infrastructure gets embedded into the things that we live and use, then if it fails, whatever we live and use will fail. So, the ability to actually destroy our society through the IT infrastructure will actually increase. Cyber attacks is probably the biggest threat to our energy system here in the United States today, right? Somebody getting into some of our electric generating power plants and shutting them down. So, yes, sir.
Actually, I had a quick question on Watson and others bring that up. How do your scientists train Watson to fight against cyber attacks like that?
we didn't train Watson to fight cyber attacks. In fact, Watson has been isolated from the internet on purpose. Because if you have access to the internet, then any question I ask you, you can go find out in the internet. You can Google it. So, no, we didn't train Watson for that. We trained Watson to learn about as many subjects as we could so that when the categories came up, it would know something about it. Does that answer your question?
Your comment about security reminds me of Stuxnet.
Of
Stuxnet,
uh,
which is the computer code that penetrated the computers in the nuclear facilities in Iran.
yes, last year,
Right.
yes.
So
That's one that we probably planted over there.
exactly, exactly,
Yeah. Well, it could happen the other way around.
Exactly.
In fact, it's already happened.
right,
We just don't know about it.
sure.
That is a big issue. That is a real big issue. If in the future we have some significant enemy like we had during the Cold War, and they figure out a way to get into the IT systems of the United States, they could do a lot of harm, incredible amount of harm. Not just turning off power, but turning off water systems, or making them destroy themselves, right? So
It's no different really to the atomic bomb, which ended the Second World War, but now is one of our greatest concerns.
the proliferation, yeah. We view honest, in earnest efforts to deal with this issue of privacy and security going on. People acknowledge this, but it's being dealt with in each country on its own. That's the concerning part, right? Because every country has their own way and approach. So, last but not least, this widely interconnected, widely instrumented, smart world that is a possibility will be the ultimate democratic process. You know, today leadership, the model of leadership comes from a superhuman person who has incredible vision and has the capability to inspire others to do what they couldn't do without him or her. That's the traditional leadership model that we're used to for thousands of years. We see the possibility to have different styles of leadership here. More collaborative leadership, more teamwork-based leadership, more leadership by listening rather than by talking. Inside our company, frankly, the people that are rising the fastest through the management ranks are not the ones that are dictators or that have an iron fist or that have an incredible work stamina. It's the ones that are best able to listen, the ones that are best able to collaborate, iterate, interact. It's the ones that are best able to inspire through their intellectual capacity, but also their ability to work as a team. It's actually a change inside our company over the last 10, 15 years. And we believe that this technical capability will require and enable that new model of leadership. We're actually very optimistic about this industry, about this science, and I'm personally excited to see so many of you here from information technology or computer science. We believe in our case that our best years are still ahead of us, and it won't be, my guess is 7 to 10 years from now, it won't even be about services. It will be about something else.
Do you want to have a guess?
Yeah.
You want to predict?
Yeah, it'll be about software. It'll be about taking business processes and converting them into software in a very quick and efficient way. and then making them interconnect, have the ability to interconnect them everywhere. It's already happening. In fact, it's our strategy that we're trying to execute inside IBM. If you look at our corporate evolution, we were mostly a hardware company, then and mostly a services company, and now we're trying to take that services intellectual property and knowledge and embedding it into software, so that it's an asset-based services delivery model, which is more effective, more efficient, more profitable. So
So you're not trying to save the world, instead you're trying to make money?
Oh, we're definitely trying to make money. Because if you don't make money, you don't get to save the world. You could ask that question to DEC, for those of you that know who they were, or Data General. Somebody told me they worked for Data General, or I don't know, Univac and Sperry and all of these firms that were huge companies back in the 70s and the 80s, and they're now gone. Nobody remembers them. So we do measure success by money, no doubt about that. But I am particularly proud to say that I work for a company that invented what's inside most of your systems at some point, at least in concept. And it was normal people like you and I who had a commitment to technology and technical learning, and who went in and, through sweat and tears and focus, invented something that got connected with something else in the company, and out comes out a unique implementation of something in technology. So, yes, sir.
What do you think are the biggest challenges to be able to get to that point? If you could think of a few things that are preventing us from moving in that direction, that you could think of ways of removing those obstacles. What would those be? If you could trace a path to get there very quickly, but there was something that was preventing you from getting to your vision, what are those obstacles do you think are doing?
It's the first two items here. I mean, there's still people trying to drive systems, proprietary approaches, and policies to try to get their own advantage at the disadvantage of the rest of the system. This is not going to be a popular statement, but it's true. The great products from the Apple Corporation are closed systems. They're perfectly closed systems. They control anything that goes into that platform. So if one day their level of innovation goes out the window, that whole platform is dead, because nobody else can get into it. So that's a danger right there, right? So that's one thing. The other one is politics and governments, right? And political philosophies and all this stuff, right? Right now, it hasn't happened yet, but this country is still fairly free and fairly open-minded and progressive. But I worry what would happen 10 years from now or 20 years from now when China finally emerges as an equal superpower, and we get into another Cold War, right? Different enemy this time. Will that create some tension in systems to block this global integration that's going on? Those are the two that come to mind. I'm sure there are others, but.
What do you think of the internet is the biggest driver of this globalization of information.
Mm-hmm.
And there's a lot of people that are trusting, like you were saying, they're trying to control it. Like, for example, like the technology exists for me to make free calls
Mm-hmm.
to any place in the world, but there's people that are trying to control it, like you said.
Mm-hmm.
So how are we going to be able to get away from that? I know there's a lot of politics, but are there any people that are working on pushing these issues to actually make the internet
I actually, it's interesting. I haven't heard I don't perceive the internet as closed at all, by the way.
Well, no, I'm not saying that it's close, but there's people that are actually preventing some of these technologies to actually be used in a global.
Yeah, but those are, I mean, government is the only one that can fix that, right? This company is trying to leverage the internet infrastructure for their own benefit and nobody else's. Government has to step in and use their power of antitrust and all of that to prevent that from happening. And they're kind of watching a couple of these companies closely right now, right? Because they're kind of on the verge of making that mistake. IBM made that mistake. I don't know how many of you know. We were sued by the US government in the 70s for antitrust. That's kind of the Medal of Honor of a real powerful company. Yeah. It teaches you a hard lesson. We almost went out of business after that. Yes, sir.
Richard says, he's adopted it now, it's his statement, that we need more engineers to be leaders and more leaders to be engineers. Would you like to comment on that based on your 26 years of experience in IBM?
I wholeheartedly agree. I haven't heard that phrase, by the way, but I wholeheartedly agree with it.
We have one congressman, if I'm not wrong, who's an engineer.
Really? I'm surprised to hear that.
Only one. As an example.
I think.
How many presidents of US universities are engineers?
I don't know. I will tell you, in the technology field, it's very common for leadership to be engineers. It's not strange. In IBM, even people like me who are in sales normally start in technical degrees with technical careers, because you can't live in this IT world if you're not technical. Very hard. So I very much agree with that. I actually believe it's quite possible and it's quite prevalent in certain industries. Maybe government is not. Maybe academia is not. But to help do that, some of the conversation we had earlier today, to help do that, I believe if you're in an engineering or a computer science track right now, you need to make sure you take some of the basic business classes. Because you have no idea how much you don't know. You think you know, but you have no idea how much you don't know. So even if you don't like it, take an accounting class. Even if you don't like it, take a public speaking, communications class. Even if you don't like it, take an organizational theory class. So you understand, how to operate in complex organizations, how to team, how to collaborate. Even if you don't like it, go down that path, some of the liberal arts. I'm actually not a fan of history or literature or any of those. But psychology. You have no idea. You could have the most powerful CPU inside that head, but if you can't spit it out and inspire somebody else to act on it, it's meaningless. And I say that to my son and my daughter. And they look at me with a blank stare, just like all of you are. Hopefully you remember this after you've been in the workforce for a few years. Yes, sir.
Wilfredo, I'd like to come back to this open source, the open technology issue. I mean, to some extent, I think IBM started that. You talk about the Macintosh, but that whole IBM,
the PC.
PC democratization. Well, IBM is what democratized.
Yep.
Not
Yep.
as opposed to Macintosh.
Yeah.
Company. But you also noted, though, that IBM, rightly so, is the leader and has been for, you said 17 years. I thought maybe it was 20 or longer years in terms of IP, intellectual property development. But if you take where you think IBM and where we need to go, we could go to a place where we're going to open source type of technology development. And that then leads us to relook at the whole IP world and how we protect intellectual property, because if we do it now, we're going to be developing technology in a more open source kind of environment. Have you thought about that, or is there a
Oh, yeah.
about where we're going with that?
Oh, yeah. There are huge discussions since we have the biggest patent portfolio in the planet, in the United States, I should say, probably in the planet. I don't know enough to be good about my response. I will tell you this. IBM has consistently put some of its patents into the open source community for free when we judged it to be in the industry's best interest. There's hundreds, if not thousands of patents that were released for free. But we're being selective about that. Right now, probably IBM's biggest concern over intellectual property is with China and software. They don't respect any of it still. Yeah, well, yeah. So, sorry, I'm not smart enough about the subject to have a point of view, except that there's a whole intellectual property department inside IBM, and we're trying to influence government policy on it, especially in China. That's going to be kind of a war zone here. It is already a war zone, especially in the smartphone segment right now. Yes, sir.
You know, it's obvious that IBM's pushing the envelope of this technology, the information technology. But you know, every business has competitors. Who do you see as pushing you, or who are you competing with in this area?
We compete with everybody, but the one we're concerned the most is Oracle. Yeah, that's probably a surprising answer, isn't it? Is that another question, or are you going to make a comment? Hang on, I'll come back. The reason we're most concerned about them, because we believe the value in this industry is moving to software, and that's their route, and they are good at executing. We're not concerned as much anymore about Microsoft, and that's going to sound a little arrogant, but it ain't. Microsoft was our thorn in our side, for the last 20 years. We're not as concerned about them anymore. We're more concerned about Oracle because of their enterprise focus, their software focus, and their ability to execute. They got the financial resources to execute. Beyond Oracle, we're concerned about everybody, but they all have their problems, right? HP has had very big problems recently. Dell is a commodity player, so they all have their crutches. So, you had a question or a comment?
Yeah, I was actually curious more, how is Oracle, like, your biggest competitor? I know you're talking about, like, I'm just curious more, like, is it because their software is mostly used in almost every single piece of...
Oracle has one of the broadest portfolios of enterprise software in the planet. We're in the enterprise space, not in the consumer space. So they have one of the broadest software portfolios of enterprise software in the planet. They also have the most successful database in the planet. And they now have, they just bought recently, hardware infrastructure to try to integrate it. They bought Sun Microsystems, right? We don't worry about their hardware. We worry about their software. Their hardware is getting killed. So that's why we're worried about it. They're building an integrated stack. By the way, another closed system. Another closed system. And by the way, we go in cycles. You're young, you don't know this. Right now, most things are open and freely exchanged, but the whole industry is moving in a closed direction right now. And 20 years from now, all the customers are going to be frustrated, and they're going to move in the opposite direction. So, there's another question up there.
Well, I just have a follow-up question on the conversation. I'm just having troubles getting everything to think about your business model because you're saying that you will be pushing for open standards so that probably means that you will have a lot of software out there that will be accessible to plenty of communities. So then where is actually everyone going to be making money? If you're asking for
in building the advanced software that rides on top of that open standard software that automates, that provides the insight, that provides the decision-making capability to solve the world's business problems. Transportation efficiency, power distribution, you know, some kind of design processes, right? So the more we standardize the base, the more the value moves towards the top. And since we see the value moving towards the software, if we standardize the base and we're over here in the software side, the value is moving here, we will be better at building these complex systems than anybody else. And that's where we make our money. In fact, right now our stock is near an all-time high because of that play we've been executing for the last 4 or 5 years. So I have to give credit to our leadership. They thought of this actually 5 years ago, 6 years ago, and quietly began migrating us in that direction. Who knows, you know, what will happen 5 years from now? Certainly, between now and 2015, we have clarity of where we're heading, but beyond that, we don't. So.
I think we'll go ahead and wrap up the formal part of the discussion here.
Okay.
I'm sure Mr. Sotolongo will be happy to talk with you individually.
All right, thank you.